Hey y'all, it's Becca. I'm a math, physics, and astronomy tutor here at Chegg. If you ever need such a tutor, feel free to hit me up at my profile, which is linked below. But today we're going to talk about comets. Comets are some of an example of the really interesting things that live in our solar system. So first of all, let's talk about where comets actually are in the solar system. They can be anywhere, honestly. They can be dispersed throughout the solar system, and where they are really depends on where they are in their orbit. But generally, in our standard model of the way that we understand the solar system is we have the sun at the center of mass, and then we have these 8 or 9 planetary bodies that orbit around the sun with asteroids and things. There's a fairly prominent asteroid belt in between Mars and Jupiter. And then we have the gas giants, and then we have what's called the Kuiper belt outside of the orbit of Neptune. The Kuiper belt is where dwarf planets and asteroids like Pluto live. And then outside of that is something called the Oort cloud. Now, the Oort cloud and the Kuiper belt are kind of these diffuse areas where asteroids, dwarf planets, and comet nuclei live. Way out beyond the orbits of the gas giants, far, far, far away from the sun. These bodies are still gravitationally bound to the sun. And out in the Oort cloud is where we find a lot of comet nuclei. Now, comets as they are out there are just these little rocks made of just ice and rock and metallic material and things like that. But they don't actually have a tail when they're out far away from the sun. But comets tend to have, depending on which one, they tend to have particularly elongated orbits. So their orbits will take them far, 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 far away from the sun in this very skinny orbit. And then as they come back in, some of them come quite close to the sun. And they don't actually develop their tail until they get close to the sun. And that tail gets larger and larger and larger as they get closer and closer to the sun. So comets actually have 2 different types of tails. As they are approaching the sun, one of their tails, kind of in the line of motion, let's say it's going this way, is a dust tail. And it's kind of like this diffuse little dusty tail, material being blown from the nucleus here. But it also has a secondary tail called the plasma ion tail. Now, this tail may or may not be pointing in the same direction as the dust tail, but it is pointed in the opposite direction as the sun. So let's say the sun is over there. The plasma tail will be over here in the opposite direction. And the reason for that is because the plasma tail is something that's formed from the solar wind. The solar wind is this very energetic wind that comes from the sun and the sun's activity. And the sun releases energy over multiple wavelengths in the spectrum. And some of the higher energy wavelengths hit the comet nuclei and actually ionize the material around the comet nucleus and form this ion tail that is always in the opposite direction as the sun is. So not only do we have this little diffuse dusty tail from sunlight pressure, we have this plasma ion tail that is essentially formed and affected by the solar wind. Now, this is something that we can actually physically see when we're observationally looking at comets. And let's say a solar event has happened, a solar energetic event has happened. We've actually seen plasma ion tails kind of like flap in the wind, like a windsock would here on Earth, but it's a comet kind of flapping in the solar wind, which is kind of cool. So just kind of to rehash that. Let's pretend our comet lives out here in the Oort cloud normally. But as it comes in towards the sun, it starts to develop this plasma ion tail. And as it gets closer and closer to the sun, this plasma ion tail gets larger and larger and larger until it's at the closest distance it will be from the sun. It's perihelion distance. And then as it continues in its orbit, that tail continues to point away from the sun, but it shrinks until it's away from the brunt of the sun's impact. So comets are very interesting to study because they only come around every so often. If their orbits are fairly large, then we only see them every 10, 20, 50, 100 years or so. Sometimes shorter, sometimes longer. It just depends on the orbit. So some of the more interesting comets that scientists have been studying lately are called Sungrazers. These are the ones that live far away from the solar system but have really, really skinny, or far away from the sun, but they have really, really skinny orbits. And as they come close to the sun, they actually get really, really, really close to the sun. And if those comets survive such a pass, it's an interesting scientific problem to look at them at the other side of that sun passage. However, a lot of the time, these sun-grazing comets vaporize as they get to that close flyby of the sun. So that's disappointing, but maybe one day we'll be able to see a sun grazer survive its solar impact, and then we'd be able to study things like that. So this is kind of an intro to the anatomy of a comet. If you'd like to chat more about comets or any other astronomy topic, feel free to hit me up, or any other astronomy tutor here on Chegg. Okay, bye guys.